If you think you and your neighbor buying an electric vehicle is what's driving the global energy transition, you are, well, you're looking at the wrong numbers.
Yeah, completely.
Because we are currently in the middle of this silent, massive revolution where corporate entities are spending literally €250 billion to electrify commercial fleets. And it is happening right under our noses.
Right, because the consumer market gets all the flashy headlines. Like we fixate on the design of the new luxury EV or, I don't know, the latest family SUV.
The stuff we actually see in driveways.
Exactly. But the sheer force that's reshaping our roads, our infrastructure, and honestly, the power grid itself
Right.
is driven by the delivery vans bringing your packages, the company cars leased by the thousands, and those massive, heavy commercial trucks moving freight across the continent.
Welcome to our deep dive into this silent revolution. Today, we are tearing into a stack of fresh sources that, frankly, completely change the way we need to think about transportation.
It's a lot of ground to cover.
It is. We are pulling from this massive, brand new report from Eurelectric called Fleet Forward. We also have some incredibly detailed technical specs from an Australian company called Alpine Energy and some breaking industry news regarding a, frankly, wild joint venture between Octopus Energy and the battery giant CATL.
Yeah, the Swaptopus news.
Swaptopus. We'll get to that name later because I love it. But our mission here is to uncover why corporate fleets are the real engines driving the EV transition and how they are literally engineering their way around the physical limits of the power grid.
I think the sheer scale of the corporate fleet sector provides the necessary context here before we even get into the weeds.
Right.
Because when we define fleets in this context, I mean, we're talking about 60% of all new car sales in Europe.
Oh.
Yeah, 60%. And when it comes to the light vans and heavy trucks, corporate fleets make up virtually 100% of those sales.
So it's not even a consumer market at that point.
Not at all. And they account for roughly 45% of all direct road transport CO2 emissions. So if the corporate logistics sector transitions, the entire global automotive manufacturing base has no choice but to follow that demand.
Well, I have a statistic here from the Eurelectric report that shows that transition isn't just, some future projection anymore.
Or the December numbers.
Yes. As of December 2025, battery electric vehicle sales BEVs actually surpassed petrol car sales for the first time in the European Union.
Which is just a massive milestone.
Right. It was 22.6% for electric compared to 22.5% for petrol. So, I mean, the tipping point just happened.
It did. And what's vital to understand about that tipping point is the motivation behind it. Because corporations haven't suddenly decided to absorb massive costs just to be, environmental champions.
Right. They're not doing it out of the goodness of their hearts.
Yeah, exactly. Goodwill alone does not move global markets at this speed or scale. This transition is happening now because fleet managers and logistics companies have run the numbers, and the economics have simply become undeniable. We really have to look directly at the math.
Okay, let's unpack this math because the numbers in this Fleet Forward report are absolutely staggering. The projection is that full fleet electrification could save companies up to €246 billion in operating costs by 2030.
Yeah, 246 billion.
But I have to challenge the reality of that figure for a second, because the sources also note that a heavy electric truck can cost, 2 to 3 times more upfront than a traditional diesel one.
Easily, yeah.
We are talking upwards of €250,000 for a single heavy commercial EV in Europe. So how does spending €250,000 upfront per vehicle translate into €250 billion in savings for the whole industry?
Well, it requires looking at a concept called total cost of ownership, or TCO. The capital expenditure, the CapEx, which is that massive €250,000 sticker price you mentioned, is really just the entry fee. For a fleet operator running a vehicle constantly, the operating expenditure, the OPEX, makes up 60 to 75% of that vehicle's entire lifetime cost.
Wait, really? 75%?
OPEX is the daily fuel, the routine maintenance, the replacement parts, and most importantly, vehicle downtime. When a truck isn't moving, it's losing money.
So it's the daily grind that actually drains a logistics company's bank account.
Exactly. And on the OPEX side, EVs completely change the mechanics of vehicle wear and tear. Like, think about the brakes. If you are hauling 40 tons, the wear on traditional friction brakes is immense.
I can imagine.
But with an EV, regenerative braking uses the electric motor to slow the truck down, which shifts that kinetic energy back into the battery.
Oh, right. So you're barely even using the physical brake pads.
Exactly. That must save thousands in brake pad and rotor replacements alone over the life of the truck. Now, we do have to balance that by acknowledging EVs are heavier due to the battery packs, which can, increase tire wear a bit.
Fair enough.
However, when you eliminate the internal combustion engine, you remove thousands of moving parts. There are no oil changes, no complex exhaust after treatment systems, no transmission rebuilds. Overall maintenance costs drop by 20 to 40%.
That's massive.
It is. And then you combine that with fleet-level software telemetry.
What does that do?
It optimizes charging times to use the absolute cheapest overnight electricity rates at their own depots. So when you stack all that up, that €250,000 upfront cost gets amortized surprisingly fast.
Okay, the daily savings make sense. But there is a lingering fear that I think anyone listening who has owned a smartphone understands perfectly.
Battery degradation.
Yes. What happens when the battery dies? If a fleet manager buys a €250,000 truck, they have to be terrified that in 3 or 4 years, the battery will be shot, the residual value of the truck will plummet to zero, and they'll be on the hook for a 6-figure battery replacement.
It's a super common fear.
Yeah.
But the Euroelectric report directly addresses this with hard, real-world data, debunking what is arguably the biggest myth in the industry right now.
What do the numbers say?
They cite this comprehensive study by Geotab that monitored 10,000 electric vehicles over time. And the telemetry showed an average annual battery capacity loss of only 1.8%.
1.8% a year.
Yeah.
That implies these batteries could function for 15 to 20 years before they hit a critical degradation point. How are they keeping the degradation that low when we're constantly fast charging them? I mean, my phone barely makes it to year 3.
Well, it comes down to sophisticated thermal management systems.
Yeah.
Unlike early consumer EVs or, your smartphone, modern commercial EV batteries are actively liquid-cooled and heated.
Oh, so there's actually fluid running through them.
Exactly. The battery management system, the BMS, is essentially a dedicated computer constantly pumping coolant or heat through the pack to ensure the chemical cells stay in their optimal temperature zone.
So it doesn't matter if it's freezing outside or if the truck is pulling a huge load up a mountain.
Right. The BMS keeps the battery happy. Another study by Takara looked at fleet data and found that even after 120,000 kilometers of heavy use, the batteries consistently retained over 90% of their original state of health.
That's incredible. The engineering has clearly outpaced public perception here. So, okay, the total cost of ownership math works beautifully for the light delivery vans, making local drops and charging at the depot overnight.
Yeah, that's the easy part.
Right. But when we scale this up to the heavy commercial vehicles, the long-haul trucks crossing the continent, this transition hits a massive physical roadblock.
The power grid.
The grid. The sources estimate that electrifying Europe's commercial fleets will demand 140 terawatt-hours of electricity by 2030. That's displacing 95 billion liters of diesel fuel.
It's a scale that's hard to even wrap your head around.
It is. To visualize that bottleneck, trying to charge a massive long-haul electric truck on a standard fast charger is, it's like trying to fill an Olympic swimming pool through a garden hose. You would literally be sitting there for days.
And logistics operators operate on ruthlessly tight schedules. I mean, they don't have days.
Right.
In Europe, heavy truck drivers operate under legally mandated resting rules. They generally have a strict 45-minute mandatory break after 4.5 hours of driving.
Oh, so the schedule's already locked in by law.
Exactly. The entire continental supply chain is synchronized to that specific rhythm. A trucking company cannot park a vehicle for 6 hours to charge. It fundamentally breaks their entire business model.
So if they can't sit there for 6 hours, they need a cable that can handle a frankly terrifying amount of current.
Oh.
They have to replace the garden hose with a fire hose.
Yes. And the industry's answer to the fire hose is the megawatt charging system, or MCS.
Yeah.
Commercialization of this standard is expected to scale up rapidly by 2026. These advanced chargers are engineered to pump 700 to 800 kilowatt hours of energy into a heavy truck in just 30 to 40 minutes.
Okay, let's pause and process that number for a second. 800 kilowatt hours. A standard home uses what, maybe 30 kilowatt hours in an entire day?
Give or take, yeah.
So you are essentially funneling a small neighborhood's daily power consumption directly into a single truck chassis in the time it takes a driver to eat a sandwich.
Pretty much.
The thermal load, the sheer heat generation on that charging cable must be immense. How does it not just catch fire?
Pumping that much amperage creates extreme resistance, yeah.
Yeah.
So to prevent the cables from melting, MCS uses active liquid cooling within the cable itself.
Wait, the cable is liquid cooled?
Yeah. Coolant is constantly cycled right alongside the massive copper wires.
Hmm.
That's what allows the charging time to perfectly align with that legally required 45-minute rest break without the equipment melting down.
That is a phenomenal engineering feat inside the cable. But it implies a massive problem outside the cable. Because if you have a major highway truck stop with, say, 20 of these megawatt chargers running simultaneously, you are pulling the power equivalent of a small town.
Yeah, exactly.
A standard local power substation simply cannot handle that kind of draw.
No, it can't. That level of demand requires tearing up infrastructure, laying much thicker high-voltage cables, and building entirely new substations. And this actually brings us to a critical geopolitical context highlighted in the Eurelectric report.
Right, the global competition side of things.
Exactly. Europe is currently in a very precarious position regarding this infrastructure, whereas China is dominating the heavy electric truck space.
So what is the mechanism behind China's dominance here? And just as a quick reminder for everyone listening, we are simply breaking down the market dynamics and infrastructure strategies outlined in the report. We're not taking a stance on any political systems, but strictly looking at the logistics. How are they scaling this so much faster?
Well, China approaches the energy grid, vehicle manufacturing, and technology infrastructure, not as separate competing industries, but as one vertically integrated system.
Ah, so it's all connected from the top down.
Right. They coordinate the supply chain from the raw lithium refining to the state-backed utility companies upgrading the grid, straight through to the truck assembly lines. Because they synchronize the manufacturing subsidies with the infrastructure rollout, they achieve economies of scale that are just currently unmatched anywhere else.
And that vertical integration shows up directly in the pricing, doesn't it? Because the report notes Chinese electric heavy trucks are landing in Europe priced between 80,000 and 120,000 euros.
Yeah, compare that to the 250,000 euros for a European-made truck we discussed earlier.
That is a massive undercutting of the domestic market.
It is. If European infrastructure and manufacturing cannot match that coordinated speed and scale, domestic automakers face a very real threat of being completely priced out of the heavy commercial market.
Which really sets up the biggest problem we've discussed so far. Because megawatt charging requires tearing up the local grid to lay new cables and build substations, which takes years of permitting, planning, and construction.
Decades, sometimes.
Right. And fleet operators can't wait years to deploy these vehicles. So what is the engineering bypass? If you can't push massive amounts of power into the truck quickly because the grid can't handle it, you separate the battery from the truck.
Yep.
And this brings us to the breaking news regarding Octopus Energy and CATL. Here is where it gets really interesting.
Yeah, they have formed a joint venture to tackle this exact infrastructure bottleneck, utilizing a technology called battery swapping.
And they gave it an incredible name, Swaptopus. I love that they leaned into it.
It's very gashy.
So instead of plugging the truck in and overwhelming the local grid, you pull the heavy truck into a specialized hub, automated robotics physically drop the depleted battery out of the chassis, slot a fully charged battery in, and the driver is back on the road in minutes.
Zero charge time for the vehicle itself.
Right. It's essentially treating a giant truck battery like AAA batteries in a TV remote.
That's a good way to look at it. And CATL, which is the largest battery manufacturer in the world, they've already proven battery swapping at scale in the Asian market.
So this isn't just theoretical.
No, it's proven tech. They primarily use lithium iron phosphate, or LFP, battery chemistry for this. LFP cells are incredibly durable, they degrade even less than standard NMC batteries, and they handle the constant cycling and the physical swapping exceptionally well.
And what's the timeline for Europe?
The joint venture plans to open these hubs in Europe starting in 2027, eventually scaling up to support 300,000 heavy trucks.
Okay, that brilliantly solves the charging time problem for the driver. But it creates a new question in my mind. If you have a hub supporting thousands of trucks, you have hundreds of massive batteries just sitting in racks waiting to be swapped.
Yeah, you do.
That sounds like a lot of dead inventory tying up capital. I mean, they're just sitting there doing nothing.
But they aren't doing nothing. That is exactly where Octopus Energy comes in, bringing their energy trading software and grid management expertise. Those spare batteries sitting in the hub aren't dormant. They are actively connected to the power grid, functioning collectively as a massive virtual power plant, or VPP.
Oh, wow. So they are running grid arbitrage.
Exactly.
Like at 2 a.m. when offshore wind farms are producing excess power but societal demand is low, electricity is incredibly cheap, right?
Right.
So the Swaptopus hub pulls that cheap power from the grid to slowly charge all those resting batteries, which, by the way, is far better for battery health than slamming them with a megawatt charger anyway.
Much better for the chemistry.
But then what happens at 6 p.m. when the grid is stressed because everyone gets home and turns on their ovens and air conditioners?
The flow reverses. The hub discharges the stored power from those resting batteries back into the grid when energy prices are at their absolute highest.
That's genius.
It is. Octopus trades that stored energy, generating a completely new, highly profitable revenue stream.
So they basically turn a logistics charging depot into an energy trading floor.
Exactly. And that arbitrage profit essentially subsidizes the cost of the physical battery swap for the fleet operator, all while actively stabilizing the local power grid instead of, melting it down with megawatt chargers.
It is a brilliant systemic solution, but I want to throw a wrench into this perfectly optimized highway scenario.
Yeah.
So Swaptopus hubs and megawatt chargers are great for major freight corridors. But what happens when a delivery truck or a van breaks down in a rural area, like a location with no swap hub, no fast chargers, and barely a functioning local grid to begin with?
Well, a stranded 40-ton commercial asset is pretty much a worst-case scenario for a logistics company. It cascades into missed delivery windows, broken supply chains, angry clients.
Right. And the traditional solution is what? Deploying an incredibly expensive heavy-duty tow truck.
Yeah, which takes hours and costs a fortune.
Which leads us to the most sci-fi edge case solution in our stack of sources today. This was found in the technical specs from Alpine Energy. They developed a product called the MGEN to take the high-speed charger completely off the grid.
Now, mobile charging is a known concept, but it usually involves, like, a truck towing a heavy, loud diesel generator.
Right, which kind of defeats the purpose of an EV fleet.
Completely. But Alpine's engineering approach here is a world first in its execution because it relies on vehicle-to-vehicle DC charging.
Right, here is the technical visual for you listening. A fleet operator takes a donor vehicle in their specs. They use a BYD Shark 6 plug-in hybrid truck, and they mount this 60-kilogram MGEN unit in the back.
And crucially, the MGEN doesn't have its own heavy, expensive battery pack.
Exactly. It wires directly into the BYD's own high-voltage traction battery. So the operator drives this donor vehicle out to the stranded delivery van on some rural back road. They plug a cable between the two vehicles.
And this is where the magic happens.
Right. The MGEN unit pulls direct current from the donor truck, bypasses the slow onboard AC chargers entirely, regulates the voltage, and pumps 40 kilowatts of DC power directly into the stranded van's battery.
The innovation here is the DC to DC transfer without any grid dependency whatsoever. It acts as a mobile fast charger, utilizing the existing energy storage of the fleet itself.
It is quite literally mid-air refueling for fighter jets, but adapted for ground delivery fleets.
That's the perfect analogy.
You just give the stranded asset a rapid 20-minute energy boost, enough for it to finish its route and get back to the depot, completely removing the need for a tow truck.
It really demonstrates the maturation of the electric ecosystem.
Yeah.
Because engineers are no longer just solving for optimal highway conditions.
Right. The easy stuff is done.
Exactly. They're developing robust technologies for the unpredictable edge cases that logistics companies face daily.
We have covered a massive amount of ground today. We've gone from the billion-euro OPEC savings and the thermal limits of megawatt fire hoses to grid arbitrage and mid-air refueling for delivery vans.
It's a lot to process.
It is. And we've been talking about massive corporate logistics this whole time, but I want to connect this back to you, the listener, because this transition is going to fundamentally rewrite the environment right outside your front door.
Absolutely.
The packages arriving at your house will be delivered with near-zero noise pollution. The air quality in dense city centers will shift dramatically as diesel is permanently pushed out of last-mile delivery routes.
And beyond the immediate environmental impact, corporate fleets are actively manufacturing the used car market of the near future.
Oh, right. Because corporate cars and vans are typically cycled out of service, every 3 to 5 years?
Yeah, exactly.
Which means the corporate sector is absorbing the steepest part of the depreciation curve. They take the massive financial hit, and a few years down the line, consumers get access to a huge supply of secondhand, relatively affordable electric vehicles with batteries that, as we talked about, real-world telemetry proves will last for well over a decade.
The implications touch everything from municipal air quality to your own personal finance. But if we synthesize all these sources and pull back to look at the macro level, there is a final paradigm-shifting question hidden in the mechanics of technologies like Swaptopus and this vehicle-to-grid, or V2G, concept.
Okay, I love a paradigm shift. Let's hear it. Where does this ultimately lead?
Well, for over a century, we have defined transportation fleets strictly as consumers of energy, right?
Right. They buy fuel, they burn fuel.
Exactly. They purchase diesel fuel and burn it.
Yeah.
Or they pull electricity from the grid and deplete it. But with the rapid scaling of battery swapping hubs and bidirectional charging capable of pushing megawatt hours back into the infrastructure, the math begins to invert.
Wait, invert how?
Think about it. What happens when millions of corporate vehicles and their automated depots hold significantly more battery storage capacity than the actual utility companies?
Oh, wow.
Right. In the near future, the logistics companies delivering your online orders might actually become the primary energy companies stabilizing the grid and powering your home.
That completely flips the entire script on how we view infrastructure. That invisible, silent force we talked about at the beginning isn't just steering the future of the automotive market. It might just end up powering the entire world.